Good morning, dear students. Today we will discuss session 12. It's about tangents and circles. This is the last session in chapter 1. In this session, we will recall the theorems that passed in the previous sessions in order to concentrate on them. As you know, we discussed many theorems and we give many applications on them. In this session, we will recall the theorems related to tangents from a point to a circle, inscribed angles facing diameter, midpoint theorem in a triangle, midpoint theorem in a right triangle, and Pythagorean theorem. In the adjacent figure, we recall it is a circle C. A is a point outside the circle. We have AT1 is the first tangent, AT2 it is the second tangent, and as we know from a point here A outside a circle, we can draw two tangents to the circle. T1 is the first point of tangency, T2 is the second point of tangency. What properties can be concluded? The first property, AT1 equal AT2, because two tangents issued from the same point to the same circle are equal. The second property, AO, is the bisector of the angle T1A T2, and also it is the bisector of the angle T1O T2. AO is the perpendicular bisector of T1 T2. In order to prove this, we have AT1 equal AT2. So A belongs to the perpendicular bisector of T1, T2. OT1 equal OT2 because they are radii of the same circle. Then O belongs to the perpendicular bisector of T1, T2. Then OA is the perpendicular bisector of T1, T2. As a result, we have AO is an axis of symmetry of the figure formed by the circle and the two tangents, and a result also AT1O is congruent to AT2O. What about inscribed angles facing the diameter? If we recall from grade 8, inscribed angle is the angle whose vertex is on the circle. Here, A is on the circle, it is inscribed. C on the circle, inscribed. B on the circle is also inscribed. But what about if the inscribed angle facing the diameter? Every inscribed angle facing the diameter, if you see here, B is inscribed and facing AC, AC is diameter. Every angle or every inscribed angle facing the diameter, this angle is right angle. We say ABC equal 90 degree because it is an inscribed angle facing diameter. BA is inscribed, but it's not 90 because BC is not a diameter. Also C is inscribed, AB is not diameter, so C is not 90. But B is 90 degree since it is an inscribed angle facing the diameter AC. A, P, B, it's equal to 90 degree because it is inscribed and facing the diameter AB. Same for angle C. C is also here 90 degree because it is inscribed on the circle and facing the diameter DB. Now we will switch to the midpoint theorem in a triangle. If we consider the triangle BAC, the midpoint theorem says the segment joining the midpoints of two sides is parallel to the third side and equal half its length. Here we consider the triangle ABC. X is the midpoint of BA, Y is the midpoint of BC. So the segment joining XY or the line joining XY is parallel to the third side, which is AC. Moreover, XY equal AC over 2. Here we get X, the midpoint of BA. Y is the midpoint of BC. Here we took the midpoints of two sides. We get XY is parallel to AC to the third side, and XY equal AC over 2. What about the converse of this theorem? The converse of this theorem, we should have one midpoint, and if XZ is parallel to AC, so it cuts BC at its midpoint. Now we move to the median relative to hypotenuse. When we are talking about hypotenuse, so we are talking about right triangle. What about the median relative to hypotenuse? Here we consider the triangle ABC. This triangle is right at B, so AC is the hypotenuse. P is the midpoint of AC. So from B to P is called median. And since it is on the hypotenuse, we saw that it's median relative to hypotenuse. And according to the midpoint theorem and right triangle, the median equal half the hypotenuse. As a result, we have from A to P equal from P to C equal from B to P. So as a result, in a right triangle, the median is half the hypotenuse. Now, Pythagorean theorem. Pythagorean theorem is applied to right triangle, which says the square of the hypotenuse, here is the length of the hypotenuse is C. So the square of the hypotenuse, C square, equal to the sum of the square of the other sides. The other sides have length A and B. Their sum, the sum of the squares, it is A square plus B square. So C square equal A square plus B square. The same here. If we have two sides in a right triangle, we can calculate easily the other side by applying Pythagoras theorem. Here we have also C square equal A square plus B square. If we substitute 5 square and we substitute 12 square instead of A square and B square, we get the length of C. Thank you very much and see you in new sessions.